Alright, hi everyone. So this is the second tutorial for Comprehensive Studio, Kangaroo. So today we will be looking at some of these components for line goals. And then as well we will look at some uses for magnets and snapping within Kangaroo. So last time we looked at points, and this time it will be for lines. So let's get started. Let's build our solver. So we'll give it just a second here. So we could use the regular solver, and I will turn bifocals on. We can use the regular solver, or we can use the bouncy solver, which is what I prefer to use, just so we can visualize what's going on. And we will do some tests. So first things first, we add a merge layer to goal objects. We will add a button for reset. We will add something for damping, and I will just set this to 0.9 for now. And then I will also add iterations. So right now it's defaulted at 10. Let's just add something for 10, and then I will take it down to 1, just so we can visualize everything that's going on. And then we will add a small panel to iterations just to see how many iterations it takes. And then for output, we can have, let's just say, data for this. Depending on what type of data will come out, we'll just keep it to this. And I will add a Boolean toggle so we can switch it on and off. And then I will go ahead and group these. So Control G for group, and then you can keep using this, reusing it. And I will make a copy. I'll save it here as well. Okay, so the first thing we will do is let's look at line and line goals. So the simplest one will be to maintain the length of a line. So what we will do is we'll construct a point, and we will go line SDL, and we'll move it in the X direction, give it a vector, and then for length, let's just take it all the way from 0 to, let's go 0 to 60. Oops, yeah. Plug it into length. And then we will plug this into line. And then we will use the same slider, just make a copy into length here. And what we'll do is, we have, right now you can see it's got a point, but it's not creating anything, so we need to add some length. Let's just go maybe 25. Right, so you can see here it creates a line that's at 25. And then I want to be able to visualize it, so I'm not turning on my solver just yet. Let's just add some components here. So from data, we'll pull out the curve. We will also use what we learned in the human plugin. We'll do custom preview line weights, and we'll give it a swatch. And we'll pick red, just because it looks good on black, and we'll give it thickness of 1. Okay, so we should be able to visualize our line that comes out, and what we will do now is let's begin. So right now, when I turn this on, you can see there's nothing happening because we're not really visualizing anything, and what we're seeing is actually this line. And I'm actually going to turn this off. And what we will do is, let's give it a length. So let's just say 18. And when I turn this on, iterations 1, yeah. So turn on iterations, and then absolute, I will go set boolean to true, and then yes. So always set absolute to true on custom preview line width, so it stays true to the resolution. And now we can see that it starts to do something. So I can control the length of the line that I want to constrain this to. And we can actually see it here. So there's a line coming out of this. So let's just go length, not this one, length, add a panel, and we can see how it is 25 because it's 25 here. But what we will also do is, let's make a copy of this, and we'll bring in the original line just to compare. So if I reduce this to 14, you can see that my original line was 25, and then it's constraining it to 14. So that's just a basic introduction into constraining a line length. So let's let's look at the polyline. So what we'll do is we'll create in here, we will create a polyline. Let's just make 4 random points, and then to bring this in, I'll use the curve command, set one curve. And then I will explode this, and we'll have a look at why we're doing this. And then from this, let's bring it into length. Okay, so we have panel. Let's add a length just to visualize it. And we can see how it's bringing in. It's got all these lengths, and then by the time strength 10, so let's maybe increase this to 20. And let's change this up a little bit. And once we turn it on, then you can start to see how the bouncy solver actually helps you visualize. So if I was to increase my number of iterations, you see it just kind of jumps to what the final form will be. But if I just want to visualize one iteration at a time, it actually shows me this sort of sequence, and you can see the number of iterations going before it comes to being converged. So let's increase the length, 22, and then there you can start to see how it's affecting it. So if we take it over here, let's delete this. You can actually see how it's making an attempt to take it as close to 22 as possible, which is what I've put in here for this to do. Okay, so that's an example for this. And then let's say if we wanted to turn this into a square. So what we can actually use is, let's turn this off. What we can actually use is angle. So the first thing that we'll bring in here, let's add this relay component, is line A, and then I want to be able to measure my angle between the first line and the next line. So you can use this component called shift list. Okay, so plug the same list into this, and then that just goes into line B, and then you'll see rest angle in radians. So you know, if you're not used to working in radians, what you can actually do is use radians component, and then you can enter in degrees. I want 90. Plug this into rest angle, and then the strength is at 1. Let's just say I want to take it all the way to 200, because I really want to make sure that this this happens. Okay, so we've got the angle, and then we will plug the angle into merge, and let's see what happens. So you see how it starts to take it into shape, and it's going to find a resting position. It will iterate till it finds a resting position. So it's also trying to maintain a length. It's also trying to maintain an angle. And then if I want to just make this stronger, I can take this all the way to 100, and let's just go on this again, and then yeah, you can see how all of those things start to kind of work together to bring this into a 90 position. So that's an example of how you can use angle, and also the length component. So the one thing I want to add here is, let's have a look at this component called crab, because this will come in handy in a little bit. So what this allows you to do is actually allows you to pick the vertices and move them around. So for on, it's on right now, but you can add a boolean if you want to be able to control it. So boolean toggle. Let's turn it on, and let's just see what happens. Okay, and then see how I can grab it and move it. This is a fun component. Let's actually turn the length down to 12, and then we'll start this again, and then here you can see how I can move things around. So that's the grab component, and then let's have a look at another one called magnet snap. What magnet snap allows you to do is it actually allows your points to snap together. So for example, I have all these vertices. I'm just going to reset this. Let's take the vertices in here. We will also take, shall we take the vertices from the other one? I think this is good enough. Let's just have a look at this. So range, we'll just leave that. Strength, we'll leave that. Let's just see what happens. Let's turn it on. So you can see how I can move this around. Actually, let's go in and hide the original polylines, and then you can see how you can just kind of move this around here. And then another thing I can do here is I can actually go explode this line, and I can also bring in the vertices for this one. So instead of having this in here, I can add this one, take the vertices also into this, so press shift so you can have multiples in there. Let's reset it, and now you see how I can also move this around, and it snaps. It's magnet snaps. So for magnet snaps, let's maybe turn this on. It's got strength 10. We could go strength 100, and then for range, let's turn this up. We'll make this 3. And now you can see how it just won't let go. So So if I was to actually draw, let's turn this off for a second. We'll turn this strength down, and let's say if I was to draw another polyline, and let's put that in instead of the one that we created using SDL. Put this one in. Let's hide this guy. Length will increase that. Let's turn it on. Okay. And now you can see how I can move this around. I can have a little bit more fun with this. Put this one here, fold it over onto itself. You can even magnetize the vertices within the polyline itself. This is a fun component to play with. So you can play with some of the strengths and see how that works for you. So we'll turn this off, and now we'll actually get into why we were looking at this. So what I'm going to do is I will make a copy of this. Let's go into perspective view. And let's just build a few cubes. Let's just say, for example, these are programs. Okay, so the way I'm going to bring these cubes in is I will use brep. So I'll go set multiple breps. You can even set them separately. Just for the ease of this exercise, I'm setting them together. And then once you bring it in, I'm going to turn this into a mesh brep, just because it just makes it easier to work with the components in Kangaroo. And then what I'm going to use here is actually called rigid body. Okay, and then because I have multiple cubes, I am going to use graft. So you can also graft it here, but just to keep things clean and data organized, I'm just going to use this component here, bring this into part, and then I will use Weaverbird's vertices component to extract all the vertices from this, and I will plug this into points. Plane, you could plug in, you know, X, Y, or any other plane that you want. By default, it's using X, Y, and it works for me. So I will continue to use that. And then for strength, it's at 10, and I will just leave it there. Okay, so I will plug this in. And we will flatten this before it goes into merge. The next one we will bring in is magnet snap. Okay, and so it's asking for points, so I will use the points that I've extracted from Weaverbird. Let's just hide all this. Rigid body, I'm going to hide this as well. The range, let's just maybe give it, you know, like a slider for 10, and then we can play with this. Let's just take it down a notch. Strength, it's at 10, so I'll bring in a slider for 10, just so I can play around with this setting as well. It's always about playing with these settings, and your units will matter as well. So millimeters, meters, inches, those things will also matter as to what numbers you use for this. And then coming in here as well, I will flatten this, and then this can go into the merge component. And then the next thing I will bring in, actually let's turn this on and see what happens. So I'm going to turn this on. Iterations, I will take it to 1. And then you can see here how, oh, magnet snap. Oh yeah, I need to bring in a grab component. So let's turn this off. Let's bring in grab. This can go into D3. Boolean toggle for on and off. Let's turn it on. And then I will leave the strength and the range as is for now. Let's just see how it works. So let's turn it on, reset. Then you can see how I can just kind of move it around. But you see how when you start pulling these things in XYZ, it just kind of, you know, starts going here and there. So how do we fix that? What we will do is, let's reset this. I will turn this off. And then what I will bring in is, let's say we want to keep this on a floor. Okay, so we'll build a floor and we will bring this in. So let's add, this goes into D4. And then for strength, I want to be able to play with this strength. So I will, right now it's at 1. So I'll take it between 1.0 to 10. And let's just leave it at 1 for now. And we'll see what happens with this. So now that I have a floor, let's turn it on. You can see that there's a floor, but these things are still floating, you know, because I haven't really done anything to these components. So they're still kind of hovering around, and they can fly above the floor and whatnot. So what we will do now is we'll add a load to each of these points to keep it weighed down. So you add kind of like a weight, a force. So what you can use is vertex load, and this is actually contained within the mesh goals. So your mesh comes from mesh brep. Strength, it's at -0.1. Let's just leave it there and let's see how this works. So this will come into D5, and then let's turn it on. Yeah, so you can see how it kind of starts to stay down. It's not really flying around like the other time. Like it wants to come back into a resting position. But the other thing that you can notice here is how it is kind of going into itself, right? Like it's like these solids are not opaque. Like they're allowing some level of penetration. So what we do for that is, let's see, let's turn this off. And we will bring in soft body collide. Yes. So again, we go for strength, it's got between 10, so we'll go 1 to about 10. Let's just leave it at 1 for now. And then the mesh will come in here, and then we will add this as a new component into merge. And what we will do now is, let's turn this on. And now you'll see how it doesn't really allow a level of, you know, letting it go inside one another. And then vertex loads, let's say right now it's at strength -0.1. And then I'll go to 0. Let's give it -10. Yeah, so it's weighed down quite a bit. And then floor, I will give it some strength as well, but you can see how the the vertices are falling in. So there's a bit of a negotiation there. Let's just go -1, and then button, it's true, and then we'll play with this again. Yeah, so you see how they start resting. So the idea is, this is a bit of an introduction for how this thing works. So you should be able to change these settings, and the challenge here is how you how you use it in order to make this thing work. Yeah, so see how when I turn it damping up to 1, it starts bouncing. Things just get really bouncy. So let's see, are there any other changes that we can make to this? Magnet snap, maybe we take this to 1. And we will take this to 0.99. Or you know what, let's take it to 0.9. Let's turn up the iterations. Yeah, so the goal is how do you keep it so it doesn't bounce so much and it's actually doing the things you want it to do. So please play around with those settings, and this can actually become a program organizer where you can even set up new planes. So let's say if I wanted to create a new plane on here, I could actually go on plane. I could specify a new plane for, let's say, a different floor, have the points for those meshes coming into this, and then you can use this to create different floors as well. But it's really about how you use a combination of things available in here in order to be able to use it. There's another thing actually I want to try here, which is, let's switch this out for a regular solver, just for the purposes of this exercise. So tolerance, and then we'll just go turn it on. It goes in here, iterations go in here, and what we will do is we will turn this on. So when you start moving this, you can actually see like this is actually allowing you to be a little bit more rigid. And what I will do is I will turn this back to -1. I will reset this. It starts to fly around, so in that case you need to play around with your floor settings. Okay, so this is all for this exercise. Looking forward to seeing your results in outcomes and to see how you make this work. Thank you very much.